Assalamualaikum and hi everyone. My name is Aidil Najmie bin MASROL. Uh, I would like to present my final year project, which is entitled Influence of Different Elevated Temperature on Compressive Strength of Concrete Incorporating Palm Oil Mill Influence as Partial Fine Aggregate Replacement. Okay. My supervisor's name is Dr. Muhammad Faizal bin MD Jafar. Okay, this is my presentation outline. First, I would like to talk about background studies and then problem statement, objective, scope of study, significance of study, literature review, methodology, result and discussion, and lastly, conclusion. Okay, for my background of study, we know that the important material to make concrete is sand. But sand is a natural resources where we know at some point it will be reduced from our world. So as an alternative, in this study, we are trying to use a by-waste product as a sand replacement, which is we use POME, which is which we get from the extraction of palm oil, and what we know that the POME is something that give environmental pollution. Okay. For the problem statement, we know that the sand is running low, and the cause for this problem is we know that the sand is high in demand for the using in concrete. For the alternative, we are trying to use a sludge, which is the POME. Yeah. The POME also got a problem, which is the environmental problem. This is caused by the BOD and COD content in the POME. The BOD and COD content is very high that give a negative effect to the environment. So for the alternative, we are trying to use the POME as the fine aggregate replacement, which is sand. Sorry. Okay. For our objective, we are trying to investigate the effect of elevated temperature on physical properties of concrete containing palm oil mill effluent, which is POME, as a partial fine aggregate replacement. For our second objective, we are trying to study the compression strength of concrete containing POME due to the elevated temperature. And lastly, we are trying to observe the mode of failure, which is the normal concrete incorporating POME as a fine aggregate replacement. For the scope of study, there are 5 stages, which is stage 1, the preparation of raw material for the sample. For the stage 2, we are finalize the concrete mix design. For the stage 3, we are curing process and the normal concrete POME toward the elevated temperature. Stage 4, where we are doing a testing on the sample. And stage 5, which will be collecting the data and do some analysis. For our significance of studies, we know that the sand is important material in construction, which is needed to make concrete. And right now it is running low because the high demand from all over the world. For the alternative, we are trying to use the palm oil mill influence, which is giving a bad effect to the environment, which is environmental pollution. So we are trying to do is testing if the POME is suitable to replace the sand in the concrete mix. Okay. For my literature review, this is 5 literature review that I have made, which is I have studied about what type of sludge they are using and how much percentage they are replacing for the sand itself. First is by Ahmadi. which is he is using paper slash, which is the percentage replacement is 3, 8, 12, and 16. For the second is Sonia Hassan, which are using a ternary slash with a percentage of 5, 10, 15, 20, and 25. For the next is Jase Kumar with Roda, which are using a hypo slash with a percentage replacement of 3, 5, 8, and 10. And next one is using the wastewater slash with the percentage of replacement is 1, 3, and 5%. And lastly is using a slash steel slash, which is 5, 10, 15, and 20%. And currently, me are doing the POME, which is palm oil influence, the slash from the palm oil, which is with a 1, 3, and 5% of replacement. For my methodology, this is my methodology, which I divide into 4 categories, which is raw material, selection, mix proportion, sample preparation, and testing method. Okay. For the material selection, I have using cement, which is OPC, ordinary Portland cement, which is from brand Orang Kuat. And then I have used a cost aggregate that provided by my concrete lab, and then using fine aggregate that was provided by the lab also. And for the water, I am using the tap water. And lastly, my sample, which is the POME itself. Okay, this is my mix proportion. This mix proportion was adapted by Sobolev in 2004, which is he is using this mix proportion to do normal concrete, and I have adopted, and from there I have made the mix proportion for my mix design. And for every mix design, I have include 10% of wastage. Okay, this is a mixing process, which is I will weigh the material and then mix it into the mixing machine and do a slump test, put it in a mold, and then curing in the water tank. This is the testing procedure, which is I put my specimen into furnace with different type of temperature, which is 100 degrees Celsius and 500 degrees Celsius. And then I will test their strength using a compacting stress. And lastly, I have studied the mode of failure of the sample. This is the result and discussion for my experiment. Okay, from the data, I have made the bar chart. It make it easy to understand the result. Okay, this is my bar chart. I have made into the 0 degrees Celsius, which is room temperature, 100 degrees Celsius, and 500 degrees Celsius. From what I can see from here, the edit of the POME into the concrete make the strength of the concrete a little bit low, which is for the 1% we can see it reduced a little bit, and compared to the plain concrete. Also, in the increase of the temperature, we can see that the strength of the concrete is reducing, where we can look at the 500 degrees Celsius. All the strength of the sample and specimen is cannot make into the 30 strength. Okay, that's all from my okay. From my conclusion, the palm oil may influence cannot improve the compressive strength of the concrete. From the data analysis that have been made, the usage of POME as fine aggregate replacement show that the strength of the concrete decreased due to the increase of usage of POME. Even though the usage is only 1%, the strength of on the 28 days of curing dropped from 31.43 to 30.78. Next is the maximum compressive strength for all specimens were recorded at 28 days. The compressive strength recorded is 31.43 Newton millimeter square. At the 100 degrees Celsius, the concrete start to begin dehydrate, which is lost chemical combined water of hydration and gradually weaken the paste and the paste cement bond, so making the concrete low in compressive strength. Okay, this is my recommendation for the next experiment. Maybe I recommend that the compacting of one sample is important process where we should make it more good. If we want to improve the quality of the concrete, we need to make sure the compacting is doing good. Next is increase the number of specimens to get more accurate data. In the future, it's better to increase the number of specimens where we can get more accurate the data. And lastly, the treatment of the palm oil effluent to get the suitable procedure to treat the wastage. In this experiment, I only dry it over the sun and then I put it on into the oven to make it dry. Maybe in the next experiment, maybe we can use other type of treatment to treat the palm oil influence. Okay, this is my Gantt chart for this FYP. Okay, that's all from me. Thank you.